Here we go. Okay, first thing we're going to write at the top of our paper is SOHCAHTOA. And remember, it is sine, cosine, tangent. Sine, cosine, tangent. The O stands for opposite, the A is adjacent, the H is hypotenuse. Okay? Same rules are going to apply as what we've been doing for the last couple days. But we are going to find angle measures. And we are going to round to the nearest degree. Okay, so we're going to find angle measures and we're going to round to the nearest degree. What kind of triangle do I have to have for all of these? A right triangle, so that's not going to change. Here's our first problem. We're just going to kind of jump in because what we've been doing really is going to translate to this. We're just going to look at things differently. If you don't have your calculator in front of you, you need one. Okay. So you'll notice in this problem, I know 2 of the side lengths. And what I'm solving for is the angle. Everyone see that? X is where my angle is. Okay. What's the first thing we've done with all of these problems? Label. That doesn't change. So I need to know what that angle is. So that's going to be my reference angle. Across from that angle is the opposite. Across from the 90 degrees is the hypotenuse. Next to the angle is the adjacent. Okay, so first step still the same. Everyone with me? All right. What 2 sides do you think I'm going to use to help me find the angle? Why did we choose the hypotenuse and the adjacent? Because we know them. Okay, we're choosing the sides that we know because what we're solving for is an angle. Everyone still with me? All right. Just like in the last unit, it's sine, cosine, tangent of your angle, and then you're going to set it up like normal. So which trig function, sine, cosine, or tangent, uses adjacent and hypotenuse? Cosine. Great. So the cosine of my angle, just like before, we just don't know what it is, the cosine of my angle equals the adjacent over the hypotenuse. Right? Setup's still really the same. We just have variables in different spots. Does everyone agree? Okay. Now, our ultimate goal would be to what? Get x by itself. So what do I need to get rid of to get x by itself? What's next to x right now? The cosine. I need to get rid of cosine. And to get rid of cosine, we are going to do the inverse of cosine, which is literally inverse cosine. So cosine of -1, and I'll show you how to do this on your calculator. Those end up canceling out, but whatever you do to one side, you have to do to the other side. So I'm left with x equals the inverse cosine of 38 over 45. Okay, so I'm doing the inverse to get rid of the cosine, but whatever I do to one side, I have to do to the other side. Now I want everyone to take their calculators, and I want you to locate your sine, cosine, tangent buttons. And right above those buttons, you should see inverse sine, inverse cosine, inverse tangent. Mm-hmm. Okay?
Probably going to have to hit the shift button to get this.
Yep.
Where it is, raise your hand.
So for all of you that have this calculator, you're going to hit second cosine, and you'll see the inverse cosine pop up. And then you're literally typing in that fraction, 38 divided by 45, if you press the right buttons. Inverse cosine of 38 divided by 45. We're rounding to the nearest degree. So whole number. What's going to be my answer? 32. So x equals 32 degrees. Okay, so as you move forward through this unit, you're going to have to read the directions, right? Because if you're finding side length, you're just going to use sine, cosine, tangent. If we're finding an angle, we're going to have to use the inverse of those. Does that make sense? Okay, let's do another one together. And then I'm going to have you try one or two. All right, so let's start with labeling. Across from the x is the opposite. Across from the 90 is the hypotenuse. Next to is the adjacent. What two sides am I going to use? Adjacent and hypotenuse, because I know them. Do you notice every time I circle the information that I'm using? Okay, that might be helpful for some of you. Some of you probably are fine, but that might be helpful. Which trig function, sine, cosine, or tangent, uses adjacent and hypotenuse? Cosine. Okay, so the cosine of my angle equals the adjacent over the hypotenuse. How do I get rid of that cosine? Take the inverse of it. Now, if you don't want to write this part every single time, that's fine. So I can go directly to x equals the inverse cosine of 6 over 9. I'm okay with that. If you need to write that step of multiplying by the inverse, then that's fine too. Okay, in your calculator, inverse cosine, so second cosine of 6 over 9 gives you what to the nearest degree? 48. Good. Are we okay with that? You want to try one? Okay, you try this one. Okay, so step one. Well, actually, before we even go to step one. So one person said they're doing better because they're paying attention this time around. But are we doing better because we're following directions and labeling?
I see people even circling.
And circling? Oh, okay. All right. When you follow directions, it's way easier, huh? Across from the angle is the opposite. Across from the 90 is the hypotenuse. Next to is the adjacent. I know the adjacent and the opposite. And as I walked around, everyone used tangent. So the tangent of x equals the opposite over the adjacent. How do I get rid of a tangent? Inverse tangent, right? X equals inverse tangent of 39 over 50. Now, the only issue I saw was with rounding. So when you plug that into your calculator, you get 37.9, and I want to the nearest degree. So you should have had 38 degrees. Yeah? Okay, last one. We can get, I want 100% on this. We're ready?
Last thing.
Like last? Yeah. Here we go. Across from my angle is the opposite. Across from the 90 is the hypotenuse. Next to is the adjacent. I'm using the opposite and the hypotenuse. Sine, cosine, tangent. Which one? Sine. The sine of my angle equals the opposite over the hypotenuse. How do I get rid of a sine? Take the inverse. So the inverse sine of 45 over 60 will give you 49 degrees. Okay. Hopefully, this will help when you solve for side lengths because it really is the same setup. Okay, it just depends on what you do, whether you use the trig functions or use the inverse trig functions. Questions, comments, concerns? We're good? Okay.